Assalamualaikum warahmatullahi wabarakatuh. My name is Mohsin bin Zakaria, MA11035. I've been assigned to do some research about the sensor. My research sensor is a thermocouple sensor. So actually, thermocouple is a device used to measure temperature accurately, especially when one consisting of two dissimilar metal join so that a potential difference generated between the point of contact is a measure of the temperature difference between 2 points. So how does this thermocouple work? Its work regarding to its name. The name is a thermocouple. As we know, couple means a pair. So it must have two dissimilar metal. For example, we take copper and iron rod as our experimental rod. We take two copper rod and one iron rod and we weld them together and keeping iron rod between the two copper rod. Two junctions will be formed. If both junctions are at the same temperature, nothing remarkable will be happen. So the electromagnetic field will be produced if the temperature of one junction is higher than another junction. This electromagnetic field can be measured as the voltage difference between these two copper rods. It will be very small value, either in a millivolts or microvolt range. So that means that the thermocouple does not actually measure the temperature, but it measures the temperature difference between 2 points metal. There are some experimental was conducted in the lab by using this thermocouple sensor. For example, is a heat exchanger and heat conductor. The application of the thermocouple in industry. We had some type of thermocouple like type K, type J and type T. For type K, is commonly used in the process plant, chemical production and petroleum refineries. Also, it also used for testing the heating of appliance for the safety. For type J, it commonly used to monitor temperature of inert material and in vacuum application. And for type T, it used widely in the food industry. It used mainly due to the high level of accuracy. So the difference between this type is just only the difference between the temperature. Like a type K is about -270 till 1370 degrees Celsius, and type J is from -210 degrees Celsius to 1200 degrees Celsius, and for type T is around -270 degrees Celsius to 400 degrees Celsius.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faizul Farhan bin Hamad Bidi, MA11053. Okay, my sensor is accelerometer, and I will explain to you a little bit about the sensor. Okay, accelerometer is an electromechanical device that we use to measure acceleration force. Okay, it also can be used to measure the vibration of the body. There are two types of accelerometer, which is piezoelectric effect and capacitive sensing. Usually, we will use the piezoelectric accelerometer in the lab. Okay, the working principle. The accelerometer consists of two parts, which is mesh and piezoelectric material. Okay, the mesh is attached to the piezoelectric material. When the force is exerted to the mesh will compress the piezoelectric material, and then it will cause a charge to be generated. Okay. This force, this is due to the Newton's second law, which is F equal to ma. When the force is increased, and then the acceleration also will increase. This is because the force is directly proportional to the acceleration. Okay, the charge output then will be converted into the voltage by the using of integral electronic. In this lab, we have two types of experiment that use the accelerometer, which is mass spring system and torsional vibration. Okay, this is the accelerometer that we use, which is a piezoelectric accelerometer.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Ahmad bin Abdul Hamid, MA 11078. Okay, I had done research for flow sensor. Okay, the flow sensor is a device for sensing the rate of fluid flow. Flow sensor is a sensing element used in the flow meter or flow logger to record the flow of fluids. Other flow sensors can measure the transfer of heat caused by the moving medium. The flow sensor is used to the many industry. For example, the flow meter sensor is used to verify water flow rate from the city main to individual homes or business. Okay, this is an example of a flow sensor. The flow sensor is a device for sensing the rate of fluid flow. Typically, a flow sensor is the sensing element used in flow meter or flow logger to record the flow of fluids. Other flow sensors are based on sensor which measure the transfer of heat caused by the moving medium. The flow meter sensor use the mechanical energy of the fluids to rotate a rotor in the flow stream. The blades on the rotor are angled to transform energy from the flow stream into rotational energy. The rotor shaft spins on bearing in this sensor. When the fluids move faster, the rotor spins proportional faster. Okay, can you turn on? Look, yeah, when the fluids flow faster, the blades on this sensor rotate more faster. The blades movement is often detected magnetically with each blade's piece of metal generating a voltage pulse, so that it can convert the engineering quantity into electrical signal. The sensitivity of flow sensor for standard configuration in flow range is from 4.0 to 20.0 voltage direct current. If the flow of the water or stream on this range, we will get the accurate result. If the flow below or exceed the range, it also can detect the flow, but the results are less accuracy. Okay, the flow sensor is used on the franchise turbine demonstrator. The device is used to detect the flow rate of the water flow in this franchise turbine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Azran bin Jimiran, MA 11031. Okay, I have signed to research about a sensor. My sensor is tachometer. Okay, first of all, a tachometer revolution counter is an instrument measuring the rotational speed of a shaft or disc, as in a motor or other machine. The device usually displays revolution per minute (RPM) or in revolution per second (RPS). Okay. This is an example of a tachometer. This is a digital tachometer that is used in the laboratory. The laser tachometer works by placing a tight beam of light against the rotational element. The rotational element will have one spot reflecting. Okay, you can see the laser tachometer. We have a laser one. Okay, then the tachometer measure the rate at which the light beam is reflected back. Means that the laser is used to this beam and then it reflected back to the digital measurement. Okay, laser tachometer can be a permanent part of the system, or they can be handheld to official spot measurement. Okay, how do the signal is analyzed? The signal is analyzed or the voltage generated by providing the tachometer with a direct connection. The most common tachometer are positive props and optical transducer. The transducer generate pass at a ripple proportional to the rotational speed, typically per minute. Proximity probe can detect the presence of a keyword slot. Okay, how does the signal of tachometer is analyzed? The most common tachometer are approximately probes or optical transducer. These transducers speed typically ounce per minute. Approximately probes can detect the presence of a keyword slot. The probes then generate a path at a certain fixed amplitude as the keyword slot passes. The optical transducers uses a piece of reflection tape attached to the shaft. The coincidence of the reflective tape and the optical transducers produce a pulse signal. Another application of tachometer in industry. Okay, first of all, in music industry. In music industry, the tachometer is known as hematometer. Okay, this hematometer is used to interior of blood flow. This hematometer is like a turbine-like device that is placed in artery or vein. It also can diagnose circulatory problem. Okay. The second one is in automobile industry. In automobile industry, the tachometer is used in engine drive shaft. It used to monitor engine RPMs to make it something like is fast or slow. Okay, and the third one is in aircraft industry. In aircraft industry, the tachometer is used the same way in automobile industry. It used in crankshaft in aircraft. It also used to measure engine RPM from oil or disturber.